Hi, this is Scott. I really appreciate our sponsors because they make the show possible. Today's show is sponsored by Developer Express. Become a UI superhero with Dev Express controls and libraries. Deliver elegant .NET solutions that address customer needs today. By leveraging your existing knowledge, you can build next-generation touch-enabled solutions for tomorrow. You can download your free 30-day trial at dx.hanselminutes.com. That's dx.hanselminutes.com. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and today I'm talking with David Bryant. He's the Vice President of Platform Engineering at Mozilla. He's responsible for the development and the delivery of that core underlying technology platform for Firefox. How are you, sir?
I'm great, Scott. Thanks for taking the time to talk to me today and have me on the show.
No, it's my pleasure. And you haven't been at Mozilla for too long, have you?
No, just a couple of weeks over 2 years. I had my 2-year anniversary on March the 16th. So still relative newcomer to Mozilla, but I'm an old guy otherwise. I graduated from graduate school and got my first job at Bell Laboratories in 1979. So been around for a while.
Yeah, so you were at Bell Labs during kind of those formative years of Unix.
I was tangentially part of it. I was part of a facility in Columbus, Ohio, our largest branch labs, and we were taking Unix as it was coming out of research in those days and building systems to let AT&T own and operate and monitor and manage the long-distance network. So we were building deployed commercial, although we didn't sell them, Unix-based systems on DEC hardware mostly in 1979, in the early days of Unix, and I was there through a lot of that growth of Unix into what we have today.
That's going to be really exciting because of the historical context that you have. And I don't mean to separate us generationally, but I think that there's a new generation of 20-somethings coming up. And I'm a 40-something, and I'm going to presume that you're on the high end of 40-something.
Yeah, add another 20, and you're getting close.
Right. So there are the people that I interact with, the people making the new web, the 20-somethings, the people for whom JavaScript is the metal. And I interact with them, and I'm starting to feel like the old person, only in the context of I have 25 years of historical context. Now you have 40 years of historical context that goes back even further. What does that feel like when you hear about people talking about, containers and virtualization and all these kind of things that were concepts in the 70s and 80s?
Well, I actually like it. I should also mention that I'm an electrical engineer, not a computer scientist. So what attracted me to computing was, building computers and getting things to work kind of at the metal level anyway. So my first many years of working, I was in the lab with the metal and programming it. And I definitely like that. And I've seen a number of those many generations come and go in computing, to the point where I also spend a fair amount of my time these days as a participant in the maker movement. And I love the idea that the computers I was programming on in 1979 were the size of a refrigerator, cost $800,000. And I can basically do that same kind of programming today on a Raspberry Pi that costs $10 and carry it in my pocket. So a lot of those programming concepts, a lot of getting at the metal, talking to people about interrupts and other sorts of electrical engineering things are back again, and an important part of computing for a lot more people than were doing it when I started many years ago. So for me, this is a great sort of rebirth.
It does feel like that
from a technological perspective, not my own, but
yeah. It does, but it also seems like we're standing on the shoulders of giants, not only from a layers of abstraction perspective. I'm looking to my right here where I have an Adafruit Feather, which is a tiny Arduino with a 3-line OLED screen plugged into a tiny thing. It's the size of my pinky. And right now it's connected via Wi-Fi and using, the web technologies to serialize and deserialize JavaScript and send it up to the web. And that's a refrigerator, and it's 45 years of computing history.
Yeah,
all there,
right.
And we take it for granted. And I'm like, it's taking a minute to compile. So frustrating.
Yeah, and you can take that technology into an elementary school and get those folks, the kids at that age, started on that cycle, which was not something we had any idea we could do 40 years ago. So.
Yeah. So one of the things I'm excited to talk to you about, because you're, as you said, you're genetically an electrical engineer, and the idea that you worked on the metal where every register mattered, where every bit and every byte mattered. And now JavaScript is the new metal. Is that a fair statement?
Well, see, JavaScript I think so. I mean, I understand the ongoing conversation about JavaScript and thinking about it as an assembler language. And I know we're going to talk about that topically today. I think JavaScript is, right next to the metal. It's a programming language that lets you think or have the sense that you're programming at the metal. And yet in some ways it's not. It's a very powerful, capable, rich programming language, far removed from the metal if you compare it to assembler languages that I was programming in early in my career. So it's sort of the question is JavaScript an assembler language? And the answer is kind of yes and no at the same time.
The virtual machine that it kind of runs in, the metal, the false metal, like the web is the metal in that case.
Right. That's right. The virtual computer is the web browser generally. So one of the ways we talk about WebAssembly, for example, is to say that it puts a virtual CPU inside your web browser, inside every web browser.
Okay, so let's introduce that. Let's introduce this concept of WebAssembly. There'd been lots of examples of people building stuff or transpiling or trying to get things that you wouldn't have imagined possible running in the browser. Like I remember seeing a Commodore 64 emulator written in JavaScript, but it was written in idiomatic JavaScript. What is different from that versus the formality that is WebAssembly?
Well, and there's a little bit of a story that goes along with answering that question. So you're right. It's possible to take JavaScript and think and act and use it as if you were programming a low-level language and talking to the metal. And in fact, that concept gave rise to something that was a precursor to WebAssembly, asm.js. And that was, in fact, the idea. Let's find a strict subset of JavaScript, statically typed, other qualities that would allow us to treat it as an assembler language, and not necessarily thinking that humans were going to program in it, but it could be a very efficient target for compilers such that programs written in other programming languages could be compiled down to asm.js, much as in the old days, you compiled your C code down to an assembler and then compiled assembler down to executable. And so asm.js was really the proof that this was a useful idea. And at the time, the reason for doing it was performance. The idea was that we wanted to try and provide programmers delivering experiences on the web with performance much closer to native. And so asm.js was this precursor that was successful and is in fairly widespread use on the web today in places where people need greater degrees of computational efficiency and are willing to accept the trade-offs that they have to make in terms of working and programming with asm.js. So based on the success of asm.js and the benefits from a performance perspective, it really allowed the folks involved to move on to WebAssembly, which is taking that one logical step further. And now we're talking about delivering essentially a binary machine language that can be executed by a virtual machine inside your web browser. So WebAssembly gives us that ability to use the web as a runtime for programs and programming languages far beyond what people historically think of as being part of the web.
Okay, so let me see if I can unpack this and paraphrase, and you can tell me if I got it right, because I think the audience is doing the same thing.
Right.
So asm.js was a subset of JavaScript that we know of. So it's like, here's a subset of JS. We'll only use this little bit of JavaScript, and we can optimize the heck out of it. We can, have basic types, and then the JavaScript engine will execute it as if it's doing anything else, but the JavaScript engine could optimize itself and say, oh, I see that we're doing asm.js. I'll make that even easier. And then I could go and compile things to asm.js. I could compile C++ to asm.js, which then gets JITted and run through JavaScript as JavaScript because it is in fact JavaScript.
That's right. That's right. And I think, for, again, maybe to make this a little more general, JavaScript is a language that's intended for humans to program, right? So it's a very, it's an easy read. It looks like a programming language. The intent is that humans are writing that code. They're going to maintain and debug the code. So it's written in text, like a book or a paragraph, like most traditional programming languages. And that's great for humans, but it leaves extra work for the browser. The browser has to take that narrative, prosaic JavaScript and parse it and turn it into a form that's much more amenable to what the computer is needing in order to actually execute it. And so that process takes time. It takes computer cycles. JavaScript is delivered in the web page when the browser goes to the page. And so that downloading, parsing, preparing to execute, all of the processing of that programming language is work that the browser has to do. And so we're making it easier for people and a little bit harder, a little more work involved for the browsers. And that's not a problem really, except for it's perceptible to end users. The time it takes for larger, more sophisticated applications with more JavaScript to download and then be parsed and made ready to execute is all time that the user is standing there waiting for their web page or their web application to come up and load. And so ASM.js was really the first step in sort of going beyond that traditional and well-intended, very successful model for JavaScript as a programming language.
Okay, all right. So, and then there was a time in the last couple of years where different browsers treated ASM.js differently. Firefox would compile it to machine code and cache it if it saw you loading it again. And there were experimental flags in Edge to do some, validation, some ahead of time. But other browsers chose to do nothing. Like Safari said, oh, it's JavaScript. I won't think about ASM.js any differently. You're saying now that WebAssembly, which is the next generation or the declaration that it's a good idea and let's do it right this time, it's a binary format, but it's not bytecode.
Yeah, it's a binary format that is, so one of the great things about WebAssembly is it's designed to be delivered as a very efficient layered bytecode representation or binary representation. So it saves the browser all the effort of parsing the JavaScript, and it also saves the user the time spent downloading a far less efficient representation in the text form of JavaScript compared to the binary form of WebAssembly. Okay.
So from a computer science perspective, if I understand this correctly, then, there's the parsers and the lexers and the compilers, and there's that whole process. The WebAssembly, it's a binary encoding of that AST, that abstract syntax tree, and the parser did that work ahead of time so that my mom and dad don't have to worry about that. And their
That's right.
cycles are not wasted parsing text again.
Yeah, all the humans that are going to look at your website aren't enduring time spent while that happens. It happens beforehand, and so they don't have to endure it. But yes, it's a binary representation.
That's an interesting, it brings up interesting questions around the responsibility of these dumb terminals that we have. Like I'm sitting in front of a dumb terminal right now, which just happens to have 16 gigs of RAM and an accelerated video card and 8 processors. But sometimes I feel like the refrigerators that are over at the cloud provider are just shipping strings to me, right? And I'm waiting for those strings, and then I have the responsibility of chewing them up. We're kind of shifting responsibility back and forth. It seems like WebAssembly is a recognition that, hey, that's a kind of a powerful pocket supercomputer you have there. Maybe it should do some work, and we'll split the work up between the developer, the cloud provider, and the browser itself so that everyone's doing appropriate work.
Right, and we'll do it in a way that puts a more powerful set of tools in the hands of the developer. So depending on what they're trying to do and the kind of experience they're trying to deliver, we give them more ways to actually make that happen. If they've got valuable pieces of application functionality that already exist and are written in C or C++, shouldn't make them have to rewrite that in JavaScript just to get it to be something that can be used in a web browser. So that's just one example of how WebAssembly adds to the toolkit that developers have to build ever more impressive web applications.
Mm-hmm. It seems like developers who were struggling to make impressive web applications over the last 15 years or so, we used plugins. We used DirectX and Flash and Silverlight and Java applets. But the day for plugins is over. Now with evergreen browsers and powerful things like WebAssembly in Firefox, I don't need a plugin for any of that stuff, do I?
That's right. And in fact, we haven't talked about that far back into the history of browser, but yes, in the early days, when developers needed to do something the browser just couldn't do, we allowed native plugins to extend the browser and let them do that. And that created opportunity, but it also created a number of issues, not the least of which being security problems and that sort of thing. So we have now happily advanced to the point where we have enough technology in the web platform proper that we no longer need to support plugins and allow native code to be directly executed from within the browser. And in fact, in Firefox, we have deprecated the plugin interface so that, with one exception, we don't anticipate allowing plugins to be run as part of the browsing experience on the web. And developers who would have needed that functionality, we believe, can get what they need using, for example, WebAssembly.
And this means a better experience for everybody.
It means a better experience for everybody, yes.
Yeah. This also means that things that maybe would have been, I would never have thought of, I know what portable C++ is, and I've written portable C++, but I don't think of it as really portable. Suddenly the web became a target for my C++ code.
That's right. And in fact, the web became a target for your C++ code. And so you can think about it from a programming language perspective. The web is now a target of many programming languages, and that will grow over time. But that also has implications for tool chains. So just like the web is now a target for your C++ code, if you're a game developer using Unity, for example, then the web is a target there too. So tool chains like game developer tool chains from Unity and Epic Games can actually target the web as a platform. And other tool chains, in particular, thanks to WebAssembly, can target the web as well. So it's a developer and a tool chain target now.
One of the buzzwords that I hear a lot is transpiling versus compiling. Do you make the distinction the way some people do?
I don't. And there are people that make the distinction between transpiling and compiling in the sense that they're talking about mapping from one language domain to another. But from the perspective of WebAssembly, it's a compiling process that gets the ultimately produces the binary representation that's downloaded and run in the browser.
Okay, so then if I understand correctly, then transpiling kind of more generally would be going from one source code to another that has a similar level of abstraction. So like from CoffeeScript to JavaScript would be a step. But compiling would be going kind of downstream. So C++ to WebAssembly is not from one level of abstraction to another. So it's clearly a compilation step.
Yeah, from higher levels of abstraction to lower, as opposed to approximately at the same level of abstraction.
So this almost makes me feel like, well, we've had iPhones and app stores and, this kind of like the both the good thing about app stores and the plague of the app store. The web is going to become an app store. I can play a AAA game theoretically in a browser, and it should work just well.
That's right. And we're starting to see that. In fact, a lot of people play games on the web. They do it in their web browser or on Facebook. And where those games used to have to be built targeting plugins, they can now be built to target the web. And we're seeing that directly. And that's actually a good thing. So an increasing number of web-based entertainment experiences can be built directly entirely in web technologies. And we're seeing that happen pretty substantially with the web, with HTML5, with asm.js. And as we're rolling out WebAssembly, we'll see more and more of that over the course of this calendar year as WebAssembly gets out in volume.
So as a developer, how should I think about it? Is it done? Is it rolling out, like you said, as it's coming out there? And should I tell my non-technical spouse about it, or should I just tell her, look at this cool web page?
Well, let's see. There's several questions packed there together. So it is rolling out. What we've shipped, we tend to think of as sort of the minimum viable product from a WebAssembly perspective. So we have all of the pieces in place to make it something that browser vendors can comfortably deploy, that developers can use, especially developers who may already have been using asm.js. And so it's this critical mass is there in the browsers and beginning to ship and sort of percolate onto end user machines. As those browsers roll out, there is more to come. And so we're not done by any means. There are a number of things coming in terms of enhancements that will make WebAssembly, a more capable environment in which people can deploy applications. And then also just to improve WebAssembly itself. So this is just the beginning of an ongoing series of enhancements that we'll make over time to increase the capabilities that we give developers through WebAssembly.
That makes sense. So then in the future, then you would see, your developer tools kind of be more kind of first class source level as opposed to like debugging assembly in the browser. That's
right. And so sort of categorically, there are a number of areas of activities that we're seeing happen now. One is turning the attention of the teams to debugging and integration with tools, better ways of doing, the traditional look at the source, set a breakpoint, step through the code, see what's going on. And so improving and enriching the debugging experience and integrating it with the developer tools they already are using built into the browser or otherwise. And so that's definitely an area of activity. Supporting other programming languages is another one. One of the things that WebAssembly does not yet do in its current form is handle languages that have built-in garbage collection like Java. And so there's work to be done to add support for garbage collection as part of language support in WebAssembly so that we can ultimately let people take Java code, for example, and compile it down to WebAssembly and run it in the browser. And then there are a number of ways. It's not an all or nothing thing. You don't have to abandon JavaScript and build everything in your web application in WebAssembly. You can mix and match. And so over time, we want to create a wider range of capabilities so that there are a number of mechanisms for people to build applications that represent some combination of WebAssembly and some of JavaScript. Maybe a lot of WebAssembly and a little JavaScript, or a lot of JavaScript and a little WebAssembly, and provide good interfaces between the two so that WebAssembly code can directly access the DOM, or you can easily call back and forth between JavaScript code and WebAssembly code. And so supporting a richer collection of application architectures as a combination of JavaScript and WebAssembly is also part of the ongoing work in the future roadmap.
That you and there was a lot in that answer, and I appreciate that. Unpacking one of them that I think is significant, and that helps us, all of us that are listening to your story, get an understanding about how we should think about WebAssembly. You're separating, there's JavaScript, the JavaScript we know and love. There's the DOM, and then there is WebAssembly, and they are individual actors in this larger thing. We shouldn't conflate JavaScript and WebAssembly, and moving between them. It's a kind of, the word we would use is, the word I've used historically is thunking, Thunk, but, moving from one layer to another, translating from one layer to another, calling from managed code into unmanaged code. And then you also mentioned the idea of the garbage collector. If I were to take C# and compile it to WebAssembly, C# idiomatically makes assumptions about there being a garbage collector available. Do I compile that and bring it along, or do I have the target language understand that? So I'm hearing that you're thinking about all those things to make it better for anyone to make WebAssembly.
That's correct. Yeah, I think back to the earlier statement about putting more powerful tools in the developer's toolbox, that fits that philosophy, right? So we want to give them what WebAssembly can do, its advantages, and how it can integrate with the tool chains and other things, and then set that in alongside JavaScript and all of the other techniques that they're using today, to give them a wider range of options to build, more ambitious or more expressive other kinds of experiences and applications on the web. So it's not a, either or kind of thing. It's here's another power tool, take a look and let us know what you think.
Nice. And you're working with partners. I've heard Autodesk and Unity and Epic. Is there something big coming, some big games that we're going to see? Are we going to be able to go and play a first class game in the browser soon?
Yes. Well, you can play some pretty impressive games in the browser now. We did a number of demos in collaboration with some of those partners. GDC was earlier in the year. And we showcased a number of them there. As part of our release of support for WebAssembly in Firefox 52, we provided a demo built by our friends at Play Canvas, who build some great games that are already available on the web, to really show you what a game engine class AAA game experience looks like, entirely rendered in WebGL. And obviously that's amenable to use with WebAssembly as well.
Very cool. And I know that people can go to webassembly.org/demo, and they can see things like a Tanks demo, which is a tutorial game that they exported into WebAssembly, where WebAssembly is just the target.
That's right. Yeah, take part of taking existing code and compiling it down to WebAssembly using the toolchain, and then packaging it up and deploying it with the larger web application in the browser.
Mm-hmm. One of the things that really helped me understand WebAssembly, and I'll put this in the show notes, and I would encourage everyone who's listening to check it out as well, is one of your team members, Lynn Clark. She's one of the engineers working on this, did a series of cartoons explaining kind of an intro to WebAssembly, and I found that to be very helpful. All of her posts at, I think she has a website called Code Cartoons, where she explains these things just in plain English, but with an understanding that engineers are looking at them. She looks at the historical context of how jitters came to be and how they improve things for us and how we got to this point.
Yeah, I'm glad you found that useful. We've been pretty impressed with Lynn's work. We posted on our Hacks blog at Mozilla and on her website. And you're right, it's a series of posts that are all connected together, so it's easy to sort of read them all and traverse them to explain some of the motivations behind WebAssembly, how it works the way it does, and then also talk a little bit about what's coming in the future. So a really good sort of single set of articles to read all in one place to give you that full perspective. But I'm glad you like it.
And so, as I understand, that's great. I will actually send Lynn kudos on Twitter. So as of February, that MVP, that minimum viable product, is complete. And Mozilla, you're the first browser as the time of this talk to come out with an implementation of that MVP. Is that correct?
We deployed it first in Firefox 52 in early March. Google subsequently shipped it in Chrome. So we were the first to actually put it in a released product. And Google followed shortly thereafter. And we know from the work with our other partners that it's coming in other browsers as well. So,
is this new kind of flavor of browser wars? It doesn't feel like browser wars like it was in the 90s. It actually feels like it makes it better for everybody.
It does make it better.
I felt like it was very competitive back in the day, but now not so much.
Well, it is interesting. It's still, there are elements of competitiveness, but I think this is another in a number of technologies where we've seen the browser vendors work together to define, build, and deploy, and then support technologies that just make the web better. So WebAssembly is a good example. WebGL is a good example. We see this in a number of places. We did, the web game stack work that we've alluded to. All good examples of where we at Mozilla obviously know that this technology is great and we want it in our browser, but we know that it's important that it be in all of the browsers so everyone have it at their fingertips, and the other browser vendors are great to work with in making that happen.
That's cool that that's happening. And it also feels like, because everything's being done in the open, like more than ever before, and people aren't trying to lock each other into, closed technologies, you're seeing tool chain libraries for things like WebAssembly. Like there's one called Binarian, the word binary EN, that, it's a tool chain. It's a library for C++ that helps you make your WASM easier. And it seems like that's just the start of a whole series of toolkits. And at some point, I'll just open up, Visual Studio or whatever and say, target the web, and it'll just work.
Right. That's right. And, we've built those tool chains in Scripton as part of the tool chain for WebAssembly using LLVM. So there's a lot of leveraging large bodies of work that already exist for programming languages and compiling in general to make it easy to bring those languages and that technology to the web.
Yeah. I'm looking forward to this. I wonder, though, how it will how the web will become the great app store. I don't know. I guess, will I be able to pay people for access to these things? I guess I just log in. It's just a website, isn't it?
Well, yeah. And so frictionless discovery and easy access is all part of what makes the web great. There are ways and work happening around things like payments on the web. So standards work and others there. I think you can expect those things to all come and get added to the picture later. But for now, Yeah, the idea is to put all these experiences on the web and make them part of what you do today to discover and visit and use the websites. And even with new things coming like WebVR, the same model applies.
Yeah, and those things are all coming together. If you think about wallets and mobile payments and WebAssembly, and then you brought up WebVR, each of these things is kind of converging into the dream of the open web to be able to do pretty much anything you want. We're now getting to the point where people install their operating system and then they install their browser, and they're pretty much done.
Yeah, that's right. And the intent is to make that a satisfying experience for developers too. So when they think about building something interesting and putting it in the hands of users, they think about the web as the foremost platform where they can most easily make that happen.
Mm-hmm. So if I go and download Firefox 52 or up, is WebAssembly only a desktop thing, or do you see this on the mobile devices?
No, we see WebAssembly as a mobile feature as well. I mean, the same capabilities, and in fact, the hardware that you and I use, many people use as their mobile device, is a multi-core, very powerful, GPU accelerated platform, and there's absolutely no reason why you wouldn't want the benefits of WebAssembly in the browser on your mobile device. And so that's very much part of the work that's happening too.
And that kind of brings it all the way back around to the beginning, where we think about how far we've come, that now we have these quad processor pocket supercomputers that not only have one operating system, but another one on top of it in the form of WebAssembly that I could target.
Yeah, and from the perspective of the web, there really is a diminishing amount of difference between the capabilities of platforms that we think of as mobile and platforms that we think of as fixed, not mobile. And we tend to worry more these days about whether it's plugged into the wall or not from a power consumption perspective, or what the network performance is like, than we do worrying about the capabilities of the underlying CPUs or whether they can display graphics or not. So.
Which is actually it's an extreme version of the whole browser sniffing versus a feature detection. Really, I don't care what I'm on. I just want to know how big the screen is and whether it's plugged in.
Right. That's right. And let me get at my content or my game or my virtual world or whatever, wherever I happen to be.
Fantastic. Well, thank you so much, David Bryant, for talking to us today about WebAssembly and helping get my brain around how I should think about what's here and what's coming.
Yeah, thanks, Scott. Appreciate the opportunity. We like having the chance to help people understand more comprehensively, like Lynn's cartoon, where we are and what we're working on. And it's been great answering your questions and going through where we are today with WebAssembly. Thanks for the time.
Very cool. I'm going to put all of this in the show notes. You can check out hacks.mozilla.org and take a look at some of those great blog posts that explain this. You can go and download Firefox and experience it for yourself, as well as visiting webassembly.org and looking at GitHub for the details about how the code works. This has been another episode of Hansel Minutes, and we'll see you again next week.